Hey guys, so we're starting pretty much our last lecture, which is on air pollution. This is chapter 18, so you should either have printed the chapter 18 reading guide or you can type right in it if that works for you too. But we're going to get through numbers 1 through 4. We're going to do this in 3 parts basically. So when you're talking air pollution, atmospheric pollution basically, almost anything in the atmosphere can become a pollutant if it occurs in enough concentration, which is kind of the rule in general for pollutants. Let's move her down. All right, so looking at number 1, when you're defining air pollution, you're talking about chemicals in the atmosphere. Okay, so, and we're going to talk about the layers of the atmosphere again, so it might be good to try to recall those. But you're looking at chemicals in the atmosphere, basically in the air. And you're looking at concentrations that are high enough to do something. We're harming ecosystems, maybe human-made materials, like we're going to talk about acid rain or acid deposition, and like the Colosseum and some of the statue artwork in Europe. Climate change or human health is a big one with this one too. Okay, so we've got, natural sources, and we've got human sources. So let's talk natural sources first. You might recall from when we did our biogeochemical cycles, our nutrient cycles, talking about some of these. But dust in general, dust is a particulate. Dust blown by the wind is considered air pollution. Wildfires and volcanoes produce pollutants. Volcanoes were part of the sulfur cycle. Wildfires also release carbon oxides. And then we're going to talk about VOCs, volatile organic compounds. Kudzu, for example, it's a vine. It's natural. It is an invasive species. You find it in the south quite a bit. I can't remember if we did that lecture or not, where I have a picture of it. I think we did. And it releases a VOC called isoprene. Okay, so these VOCs can interact with other pollutants given off from cars and actually create smog, which is what we're going to talk about today as well. So those are natural sources. Human sources. First of all, we need a word that I probably should have taught you a while ago. The word is anthropogenic. I can guarantee that the first question on your quiz for this reading guide is going to be, what does anthropogenic mean? It means man-made, human-made. So anthropogenic causes, if you were to be asked that in an FRQ, is what are human-caused causes, human-made causes. So the biggest one here when we're talking about air pollutants is fossil fuels. Absolutely. I'm sorry, I'm so distracted. My kids are running around crazy outside. And so you've got factories burning large amounts of fossil fuels. Think about coal-fired power plants and things like that. You've got motor vehicles. Those are our mobile sources. Okay, so the human sources of air pollution vastly outweigh the natural sources. We have technology available to reduce some of these, but it's super expensive. So now let's distinguish between primary and secondary pollutants. This is the second question. Okay, so primary, first degree, are emitted directly into the air. So they're coming straight out of our cars, they're coming straight out of our factories, and they're emitted at high enough concentrations to cause harm. Our examples are going to be carbon monoxide, which we're going to talk about in a minute. It's what you have a detector for in your home probably, hopefully. Carbon dioxide, which we're familiar with, greenhouse gas. CH4 you should recognize. That's methane. And then SOx and NOx. So this is SO2, SO3, NO2, NO3. Hopefully you're going to watch the Mr. Anderson video on the air pollution stuff, and he calls them SOx and NOx because the subscript, the amount of oxygen atoms in the molecule, can differ. This is kind of like an all-encompassing term. Secondary pollutants, then, you can watch the video on your own if you want. It's just a clip from Mr. Anderson's video. When those primary pollutants combine, sometimes with heat, sometimes with light, they form other pollutants. And so sulfuric acid is going to be one of those. That's H2SO4. When we talk about acid deposition, ozone is one of those. That's O3. I'd say those are the most common ones. You can list the other ones. H2O2 is hydrogen peroxide. HNO3 is nitric acid. I don't know what SO3 is. I should probably take it off, to be honest. Okay, so that should answer number 2. Number 3 is a fat table. So it's a list of types of pollutants, where they're coming from, and what some examples are. Okay, so after I talk through it, I can hold it up and you can like pause it and make sure you have what I have. But I am going to talk through it. Okay. These are the ones we're going to cover. It's a nice diagram that shows the primary pollutants that we listed. It shows natural sources, it shows anthropogenic sources, and then it shows some secondary pollutants. All right, so let's talk about these major outdoor air pollutants. So we're going to start with the carbon oxides. So that's carbon monoxide and carbon dioxide. So those are your examples. Your air pollutant that you can write is carbon oxide. Vehicle exhaust creates carbon monoxide. This is why you should never start your car in the garage. It is colorless and odorless and puts people to sleep, basically. Any sort of burning is also going to create this. Tobacco smoke as well. So carbon monoxide, the CO, is a colorless, odorless, toxic gas. That's why we have detectors in homes. Carbon dioxide isn't really harmful to humans. I'm producing carbon dioxide as I talk at you right now. However, you should know, and you do know, that it's a greenhouse gas. And so it's a contribution to global climate change. We're not so worried about it in terms of human health. Then we've got the nitrogen compounds. So nitrogen oxides, it should say NOx there, and nitric acid. This is where we're going to talk about photochemical smog, and then we're going to talk about acid deposition maybe next time or the time after. But again, the N compounds, the NOx, the NOx, come from burning fossil fuels in cars. Also come from coal-burning power plants. Like a whole lot of it comes from coal-burning power plants. Okay, so smog we'll talk about on the next slide, but it's this mixture, the secondary pollutant, this mixture of chemicals formed with sunlight when there's heavy traffic in big cities. We've got sulfur dioxide and sulfuric acid is our next category. These are an acid deposition. You can write the SO2 and the H2SO4. You can also write SOX, the SOX. If you remember, there's dirty coal and there's cleaner coal. That dirty coal was PBLA, lignite. Lignite was a really dirty burning, sulfur-rich coal, and so that's where a lot of our sulfur compounds come from, is burning that really plentiful, really sulfur-rich coal. Refining oil also is going to give off sulfur, as is smelting, and then not so much regular gasoline, but diesel as well. All right, particulates is kind of what it sounds like. It's particles. Soot, dust, okay, stuff like that. So the category is particulates. So they have to be small enough and light enough to continuously stay suspended, basically. So we do have, those are some human-caused sources. We have some natural sources. Just dust in general, like from soil erosion, wildfires, sea salt. Like if you go to the beach and you get like the salt in your hair, that's a particulate. But then coal-burning power plants, like think about that soot. Cars, and then road construction. A lot of dust with road construction. Ozone, this one's a secondary pollutant, still an outdoor pollutant. That is going to be the main ingredient when we make smog that we're going to talk about on the next slide. So it's not emitted from a single source. Oh, you can't read that. I got to move myself. There we go. But it's going to be a secondary pollutant created from interactions. And a lot of the pollutants come from motor vehicles and power plants. And then the last one is volatile organic compounds, or VOCs. It's a big category. As you can see, there's a lot of examples there. The one you're most familiar with is methane, right, from cattle. Formaldehyde is one. Even just like gasoline evaporating into the air, that's one. Isoprene was mentioned on the previous slide as a VOC coming from kudzu, or those vines. Okay, so this is mine. Let's see. If you want to pause it and write what's in my table. Don't look at my number 4. You're going to have more details than me on this one. All right, so let's talk about smog. So I didn't know this when I taught this course, but there's actually two types. How much time do I have? I'm good. There's actually two types. Industrial smog is kind of like what you think of when you think of like dirty, gray, black air. Like when I think of like industrial revolution, this is the kind of smog. So when we burn oil and coal, especially that lignite, that dirty coal, not anthracite, the sulfur reacts with oxygen, and then you also have this soot, and you make sulfur dioxide, which is SO2. Some of that SO2 is converted to sulfuric acid, which are tiny suspended droplets. And you end up with this like sooty secondary pollutant of industrial smog. College Board doesn't need you to know a whole lot about industrial smog. You should know that it exists, that it's this gray smog. Pittsburgh, like a factory town. London, Chicago. I don't know about Chicago as much anymore. But the picture here is of Beijing in China. And so you kind of see, like, it kind of looks like fog. Like, you kind of see that gray smog hanging over it. The one you should know more about, and like I left you a lot of space for number 4 to write, is photochemical smog. Photo means light, chemical is chemical. So this is smog created with sunlight and heat interacting with primary pollutants and making a secondary pollutant. So it's the influence of UV radiation that's creating this mixture. So here's our equation. We've got the volatile organic compounds, which are naturally given off from plants, also given off from cars. You've got NOx, NO2 and NO3, given off from burning fossil fuels. You've got the presence of heat and sunlight, and you make O3, which is ozone. It's a reversible reaction, like it can go back and forth. Mr. Anderson's video explains it in more detail. But the idea is that you're making ozone, which is an irritant to humans, in the tropospheric level of the atmosphere. The troposphere, just to remind you, is the bottommost atmospheric level. It's where the weather happens. That was from Unit 1. It's where the weather happens. The stratosphere would be right above it. That's where the ozone layer is. So like you hear ozone layer, the ozone layer is good. It's in the stratosphere. It's not by us at all, and it blocks out UV light because it kind of reacts with it. Tropospheric ozone is harmful to humans. So kind of like get that straight in your head. It's also going to make something called aldehydes and some other secondary pollutants, but we're really worried about ozone. Ozone is the primary pollutant in photochemical smog. And so I really wanted to put like the details in here. So the idea is that, picture LA, okay? Picture LA. So tons of traffic. There's like 7 lanes of traffic. I've tried to drive it before. And you have NO2 produced early in the day with this commuter traffic during rush hour. And you've got the sun beating down. And as the day moves on, it gets sunnier and it gets warmer and it gets sunnier and it gets warmer. So you're increasing this heat and sunlight right here. You're producing all these VOCs and this NOx, and so you're making all this ozone. So daily during rush hour, you're forming this photochemical smog, and it's forming and it's forming and it's forming. It's going to peak late morning, kind of after rush hour and early afternoon. Now, yeah, there's an evening rush hour too, but the sun's going down, and so you don't get as much smog with the evening commute as you do with the morning commute. You're going to see higher levels of smog in the summer because it's sunnier and it's hotter. Okay, so this is all number 4. So LA is probably the worst smog problem. We'll talk more about why, because it has to do with its geography as well, but you should, because of the amount of commuters and because of the sunny, hot weather, like it's kind of like the perfect storm for photochemical smog. We can reduce it basically by reducing driving, carpooling, reducing the NOx and the VOCs. And what you'll see when there's like an ozone warning, like, and actually the Weather Channel gives them in your phone, even for like Brookfield. It's an eye irritant, and people with asthma and other respiratory problems have to be careful. Okay, so what you see here is, this one on the top is LA. I'm going to show you a picture tomorrow, Friday, not tomorrow, whatever, the next lecture, of LA on a clear day. This is LA on a very smoggy day. And then the bottom one is Shanghai. Okay, so you should have gotten through number 4. The next time I see you, we'll keep going with the lecture. Peace.